Well, welcome everybody. My name is Nancy Moore with Africa Fire Mission. Excited to have you all here with us today and excited to have you join us. Today we have Ed Collet, who will be presenting on safe driving and some tactics around that to reinforce some of the things. Even if you are not a driver, this course is really important for us to think about in terms of how we're interacting with our apparatus. So excited to bring this topic back again and with you. So just a reminder to introduce yourself in the chat, ask questions there. Ed will make sure that at least at the end that we're checking those questions and catching those as we go along. If you have questions in the middle, feel free to unmute yourself and go ahead and ask those questions as well, but feel free to utilize the chat. I just wanted to, I know several of you are from various places and different things. So just something that has been encouraging me lately is just the team of AFM and the team of firefighters that each one of you have, and kind of the coming together and being part of something. Last night we had a preparation team meeting for our Kenya trip, and we are still planning to come in November to Kenya and working on all of those details. And it's just such an encouragement when we partner with others, when we walk side by side and work side by side with others. And so just want to encourage you to keep connecting with your team, stay connected with the team of firefighters, those that you work with day in and day out. Encourage each other and just continue on in that, because together we can do more and learn more. And really that's what these trainings are about, is bringing you together to continue to grow so that as a team, we can all do more. So with that, I'm going to pass it on to Ed to talk about driving today. And yeah. So we're having some video problems on Ed's side today. So we may have mostly PowerPoint for the visual.
Well, yeah, well, you're not missing out by a whole lot by not being able to see me. So we'll still get the main point across.
Absolutely. Thanks, Ed.
Okay. Well, I'd like to thank everyone for coming. This shows your commitment to becoming a better firefighter and also to developing your fire department as well, because unless knowledge is shared, it has no power. So, you know, we want to make sure everything we learn, we want to take it back. And as Nancy said, even if you're not a driver, this is important information, especially if you're a chief or an officer, because this is a key element in the service we provide. I'm fairly passionate about safe driving for a couple reasons. One is, as the co-chair for our water supply task force in the state of Ohio, one of the things we have issues with is water tender accidents. They are disproportionately involved in accidents, and often fatal accidents, compared with all of our other fire apparatus. So I'm a huge advocate of safe driving from that standpoint. Also, probably about 10 years ago now, a neighboring department did have a fatal accident with one of their apparatus when it ran through a red light in an intersection going to a fire, and it killed 2 people in the vehicle that they hit. So it's kind of close by that, you know, our goal is to fix emergencies, not cause more of them. So a big thing is safe driving. Now if I can get my slides to move. There we go. And I was involved in racing for many years through college, and my friends, we drove race cars for a long time. And one of the big sayings in racing is to finish first, you must first finish. And as we take that away into the fire service, that means the only way we can fix an emergency is if we first get to the emergency. And then to do it successfully, we must be able to get home as well. You know, there's the huge initiative in the US is everyone goes home, which means when we start our shift or when we arrive at the station, we go home in the same condition we arrived as. A lot of people see that just as being safe on the fire ground, but it is also being safe going to and getting back from the fire ground. You know, one of the big things as firefighters, if we can save a life, if we save a life, make a difference in someone's life and their outcome, that's our goal. And sometimes we get into the glamorization and the hero aspect of that, which is, the firefighter coming out of the building, carrying the infant or the toddler, and they save their life by pulling them from the jaws of the fire. Where I kind of look at it as, if we prevent someone from getting hurt by our driving, we're doing the same thing. If we let everyone that we pass go home safely because we didn't have a wreck or we didn't cause any type of accident, then we've done our job as a firefighter, and we've saved and preserved life because we were able to not cause harm to life as we were going to the accident or going to the fire. So, just in safe driving, we fulfill our calling to preserve life and property. Those are the big two things in the fire service: preservation of life and property. If we drive sanely, we do that. And it's not just getting there. I mean, as the driver, you're responsible from getting your crew from the station to the incident and getting the crew from the incident back to the station. Sometimes we just get focused on running, as we call it, code 3 emergency with lights and sirens. And we just get all focused on that, and we let our guard down when we drive back to the station. And sometimes that is where we do get a lot of accidents. I mean, the other place we get into accidents, and studies have shown with some of my friends in major departments, actually in my own department, we hit things that don't move. We've hit buildings, we hit trash dumpsters, we hit parked cars. Now, that doesn't, for the most part, that doesn't involve any injuries, but it damages equipment. And think about what having equipment out of service because you backed into something or damaged something does to the level of protection for your community. Not only does it lower the level of protection that, you were entrusted by the community with this piece of apparatus and you damaged it. So in a way, not only you damage the apparatus, you damage a certain level of trust. And I will say, I don't speak from a glass house because I have, just so everyone knows, I have hit a few things and caused some minor damage to our apparatus. And that was in my younger days, and I've learned a lot from those incidents, and I'm hoping that some of the things I learned will help you maybe not make some of the mistakes. So that's some of where this also comes from, of, when we get back to the firehouse and backing. One of the big things we always do is when we return to the firehouse, we always have backers in place. So people at the corners of the apparatus, to help the driver make sure he doesn't back into anything. The truck in the middle of that picture was severely damaged while it was backing, and it hit the side of the building. So now our $1 million ladder truck, it doesn't function at the same level that it should until we can get it repaired. So, those are always things to think about. How best am I going to prevent an accident or damage to my equipment? So the big things we forget about is your fire apparatus is not your car. There is a profound difference. Fire apparatus are heavier. The center of gravity, which we'll talk about what that is, it is higher. The tires don't stick to the road surface as well on fire apparatus as they do for cars. The braking system have a little bit of lag. And honestly, the biggest thing is we carry a big tank of water on all our fire apparatus. So most fire apparatus have the equivalent weight of 2 to 4 cars just in water on the apparatus. And unlike many other types of loads, the water moves. If the tanks aren't designed properly, and even when they are designed properly, you can't eliminate all the weight shift from the water. So that's a big thing that drivers have to understand is, how does my vehicle handle when the water shifts? That's why if a tank doesn't have baffles or walls inside of it to basically make the tank into smaller compartments, we usually say that they need to be driven with the tank full or the tank empty. Because when it's only partially full is when there's more movement with the water that can impact on how the vehicle handles. So now, the biggest cause of accidents, and there was a study that the U.S. Fire Service did, basically centering around fire tankers, so large, 11,000, around 11,000 liter fire apparatus for hauling water. And I've also since then did a lot of research into line of duty death reports. One of the biggest things that we see is speed. People driving too fast for the apparatus, people driving too fast for the conditions. And we'll look at it, anyone who's taken any of my pump classes, we're going to get into vehicle dynamics, because just like my pump class, where I think you need to understand a little bit of the science of what makes things work with a pump, the same goes for your apparatus. You need to know a little bit of the science about how the vehicle handles in order to understand its limits. And that's where we're really going to look at on the speed. Inattentive drivers, that was probably the second. And in my opinion, and a lot of the surrounding departments around me and my department have policies on this. Any driver that is caught by the officer using, their cell phone or anything while they're driving, even if it's not emergency, that driver is automatically suspended from driving. And the officer should stop that immediately when he sees it happening. Because the big thing is you need to pay attention to where the vehicle's going and what's around you. Going off the road is another big cause of accidents, and actually rollovers of vehicles where the driver will get, in our case, and I forget that in Kenya you drive on the left side of the road, not the right like we do. So when we get our wheel off on the right side of the road, it'd be your left, and we try to recover, that's when we get into a lot of accidents. Mechanical failures was another issue. not having good maintenance on the rigs, not keeping brakes in good condition, not keeping steering in good condition. And then the operators not being familiar with the handling of the rig. So those are kind of the big cause for accidents. Another even bigger cause of the fatalities was found to be no one wearing a seatbelt. And that is, we have 100% seatbelt usage policy in all the departments I'm on. All our surrounding departments have 100% seatbelt usage policy. We cannot be in the rig cannot move without everyone being seated and seatbelts on. You know, it is a proven fact that seatbelts will save lives if the apparatus gets into an accident. Now, we said speed was the biggest contributor to accidents. Now, we usually measure our speed in kilometers per hour, how fast we're going. There's speed limits up, 50, 60 kilometers an hour. And then we can go slightly faster than the speed limit when we're running in an emergency mode. But we should also remember, weather conditions, road conditions should affect the speed that we actually drive at more so than we're going to emergency than we're not. I think it's important to kind of reduce our speed, not from a kilometers per hour, but more look at it as a meters per second. When we look at our reaction times and our braking distances and how much space we need between other vehicles, we're looking at meters and seconds and fractions of seconds to react. So, I broke down just a little table. So if we're going 40 kilometers an hour, we're actually covering just over 100 meters per second. And when we talk about braking distance, this looking at how many meters we're covering every second really will drive home why we need to be attentive and how much distance we're actually covering before we even start to stop our vehicle. So that's why sometimes just kind of look at this in a meters per second and how much you're covering in a split seconds when you're trying to make decisions. And speed is always you can parallel the speed to the forces acting on the vehicle. The higher the speed, the greater the force, be it braking force, lateral force, whatever's pushing the vehicle, the faster it's going, the more force that there is on the vehicle. So here we'll start talking about vehicle dynamics, kind of the science behind how vehicles move. As you can see, like on the right, we're looking at a small ambulance versus a large ARF truck. So the dynamics of those two vehicles is vastly different. And some of those keys are how much they weigh, where the center of gravity is, which the center of gravity is if you would take the entire weight of the vehicle and kind of find where all of that weight is concentrated in the force that gravity pulls down on the vehicle is located. That's what we call the center of gravity. It's kind of like if you could pretend all of the weight was concentrated in one ball hanging somewhere in the vehicle, that would be what the center of gravity is. And this is the one time I wish my video was working. I do actually have a model that shows what the center of gravity actually looks like and does. But anyone that comes to the symposium in Kenya, this is going to be expounded on, and we'll be giving this presentation with more explanations and some more models as well. So the length of the vehicle has impact on how it handles, also how it maneuvers. So the longer the vehicle is, the more room you need to make a turn. So if you're in traffic, this is where, when things get a little tight in traffic, that's where we have the potential to start hitting other vehicles if we're not careful, and we haven't practiced with how tight we can turn our vehicles before we get into traffic. And that was one of my early on incidents where I did clip a parked car with the back of our engine. Everything was very tight where I was driving, and I misjudged the back tire versus the front bumper on a car. Now, fortunately, I put a little black mark on the engine, and I put a little red mark on the car, and there was really no damage either way. No one got injured, but it drove home to me needing to know where you need to be as far as the knowledge of where you are relative to your vehicle. How wide it is contributes to your maneuverability, and it also the potential for rollover. That combined with the center of gravity will determine how susceptible to rollover your vehicle is and how much force that will take. Some of the forces we're talking about are lateral, which are acting to the side. So that's going to be when we're in a corner. And then our braking and our acceleration forces, which go forward and backwards. So looking at the physics, this just kind of lays out those components, what we were talking about, kind of in more of a rough stick model. So you can see, on a tanker, this center of gravity is kind of around one of our tanker apparatus, where most of the weight is carried very high in the vehicle, just due to how the tank is configured, and the majority of the weight, it comes from the water. So it's up high, which that gives us a higher center of gravity height, which, as we'll see, will tend to lend this vehicle to roll over without much force comparing to other types of vehicles. So the important, probably one of the, if not the most important part of the vehicle is the tire. The tire supports all the weight of the vehicle. And actually, it's the air in the tire that supports the weight. It connects the vehicle to the road. That's what allows force to be transferred between the vehicle and the road. So if you think about, how, we'll say, grippy or sticky the road is between the tire to allow you to transfer force. So concrete, if you go out, it's very, we'll say, you can grip very well between a tire and concrete. Asphalt, it grips well, but if it gets hot, and when it gets hot and the oils come out, you have less traction because of that layer of oil coming out of the pavement. So the ability for the tire to apply force to the road is diminished. And weather also changes that. When it rains, the tire cannot get as much traction. I think that's something we're all familiar with. I mean, I have just personally slipped and fallen on a sidewalk when it rained, that the same time when it's dry, I have no problem on walking. But the water changed the ability for my shoes, which is the equivalent of the tire, to grip the pavement. So that's one thing we have to be aware of is, the road surface and the tires, of how well they work together, and how changes in the road surface impact the ability of the tires to transfer force to the vehicle and control the vehicle. So the limitations on the tire, tires are just like us. We can only do so much. And especially if you start asking a tire to multitask. And by multitask, I mean, you want it to accelerate and corner at the same time, or corner and brake at the same time. So this is what we call a traction circle, that shows you the force that a tire can take. So if you're going at the red arrow, if you're braking, if that would be, say, 1 unit of force, it can go all the way to 1 unit of force and have a lot of braking power. Or you can use that 1 unit of force to have cornering power and, get lateral force. But then if you're trying to do 2 things at once, like braking and cornering, well, you don't get 1 + 1 is 2. Actually, you get, it's more like about less than 1.5. So when the tire starts to multitask and do 2 things at once, it cannot exert the same force as if it's only doing 1 thing at a time. And I look at this, and this is the only time I will reference race car driving and driving a fire truck. When a race car driver goes into a corner, he doesn't keep accelerating and turn, or he doesn't brake as he's turning, because the tire works better if it's only doing 1 thing at a time. So a race car driver will brake before he comes to the corner, be at the slow speed he needs to be at to negotiate the corner, make the corner, and then accelerate. That is allowing the tire to be able to do the most work possible at any one time. So that's especially, we want to try to brake before we get to our corner, and then not to accelerate till after we're through our corners. This allows the tire to work the best that it can. And we need to check for tires. We need to check these every day. Our air pressure. We said that air pressure holds the load of the vehicle. And that's why at the very bottom, if we go back, the tires aren't perfectly round. At the very bottom, they flatten out here. So that's why we need to have the correct amount of pressure so this area doesn't grow too big. If it gets too big, it builds up more heat, and there's a lot of, we'll just say it, magical stuff that happens here into the tire construction if they're in low pressure back in this area, that causes them to fail faster than if they're at the proper operating pressure. Look for wear, especially on the tread, to make sure there's enough tread to push water out, to give us the maximum grip between the road and the tire for when it's raining, and also any damage. The tire on the right was actually on a water tender I was driving. The tread came off on the way to a training event, and fortunately we were able to get the truck back to the station without incident. But this is one reason we need to check our tires every day when we go to work and make sure everything looks okay. We don't have any cuts in our sidewalls. Doesn't look like the tread's separating. Everything is looking like the tire should. The other thing we have that's important is the braking system. So depending upon the size of the truck, it's either going to have a hydraulic system or an air brake system. And we should be checking these for leaks, wear, and also the adjustment to make sure they're properly adjusted. If they're not properly adjusted, it'll increase the time for the braking system to engage, which, as we'll see in a little bit, will increase the amount of distance we need to be able to stop. So it's important that we have good maintenance for our braking system and that our drivers are familiar with how they react. An air brake system reacts differently than a hydraulic brake system. A hydraulic brake system on a fire engine reacts differently than the hydraulic brake system in your car. So these are things, and also systems like anti-lock brakes. Most cars have anti-lock brakes. Older fire apparatus do not have anti-lock brakes. All of our newer ones do have anti-lock brakes. So those are things you need to be aware of, what your fire apparatus has and how that changes your braking capabilities. So here we break down stopping a fire apparatus, and this is where the meters per second really comes into play, as far as being able to understand how long it's going to take to stop my fire truck. Now, the first thing we need to do is recognize there is a reason I need to stop. Either the car stopped in front of me, a pedestrian ran out in front of me into the road, there's damage to the road I have to avoid. I have to recognize there's a reason for me to stop. So that takes time. This is also the reason at night and in bad weather, we want to drive a little slower, because that recognition time increases due to our inability to see as well as we can when it's during the day. So if the recognition is half a second and you're going 40 kilometers an hour, you've covered basically 55 meters, just recognizing you need to stop. Now the next portion is reaction. How quickly does it take me to pick my foot off the accelerator, move it over, and put it down on the brake? So that has to do with, the layout of the accelerator and the brake pedal, a person's physical and mental acuity to be able to do that action quickly. So if there's a quarter of a second and you're going 40 miles an hour, to go from the brake pedal to go from the accelerator to the brake pedal, that takes a quarter of a second. Now we've added another 25 meters that we covered. So before we've even started to brake, we've just traveled 75 meters. Now we've hit the brake. It takes a little time for the air system to react or the hydraulic system to react. And that's usually in the tenths of a second. So say that's a tenth of a second, but 40 kilometers, that's still 10 meters. So now we've added up. So we're 85 meters since we recognized we needed to stop. We've now traveled 85 meters. And we haven't slowed down yet. Now we start our stopping distance. That, depending upon the braking system, the weight of the apparatus, some of the other design characteristics, that can be anywhere between 100, or actually from 50 to 300 meters, depending on speed. So now, say that it takes 100 meters to stop our vehicle. We've got our 85 meters we traveled before the stopping actually started. Now we have another 50 meters, so we're at 100, 130 meters if it takes us only 50 meters to stop. So we've traveled quite a distance when the difference between hitting something and not hitting something could be 2 or 3 meters. Anything we can do to increase our reaction time, decrease our reaction times, decrease the amount of distance we travel, and decrease our stopping time. Well, one thing that impacts all of that is how fast we're going to begin with. So if we're flying down the road because we have lights and sirens on and we have to get to an emergency. And because of this, we're unable to stop before we hit the car in front of us. Well, we never did get to the emergency. So, you know, I'm always told when I tell people to slow down, they'll say, well, seconds count. I said, yeah, and so do minutes and hours when you don't show up because you hit something and we don't get there. So just slowing down a little bit can have a big impact on being able to brake in time and not hit something, or not being able to brake, not being able to stop the apparatus before you hit something. Now, one thing I do to reduce my recognition time is I always watch the vehicle in front of me, but I'm also watching the 2 or 3 vehicles ahead of that vehicle, because I know the vehicle in front of me can stop at any time. But I also know if 3 vehicles in front of him stop, he will eventually have to stop. So by looking a few vehicles in front of him, if I see they're starting to stop, I can already be lifting my foot off the accelerator and going to the brake. And that reduces my recognition and my reaction time both. So that's one thing I do when I'm driving. The other thing I do is if I'm coming to an intersection and the light has been green for a very long time, and here we call that a stale green light because it's been green for so long, I will take my foot off the accelerator going to the green light. I know many people find that counterintuitive. The light is green, go as fast as you can to get through it. But there's the possibilities you're going as fast as you can to get through it and the light turns red and now you can't stop. And the other people then see you coming with your lights and sirens on and now they have a green light and they'll pull through the intersection. Also, with that, all of my department's policies are we stop at a red light or a stop sign, even if we have our lights and sirens on. This is to make sure people have seen us and they will give us the right of way, because actually all lights and sirens are doing is we're asking other drivers to give us the right of way to go through an intersection or go past them on the road. So we have to stop and make sure they've said, yes, you can go. And then once everyone else is stopping, then we proceed. Another reason we do that, many studies have found drivers can't hear our sirens. Sirens are fairly ineffective at warning the public when they're in their cars. So that's another thing we have to realize. Just because we have lights and sirens on doesn't give us this magical bubble that just lets us fly down the road and ignore all the traffic laws and, you know, all of basically common sense procedures. We call it due regard here in the US, and not being familiar with what the laws are in other parts of the world as far as, you know, what a fire truck can do when it's running with lights and sirens. I am referencing basically everything based on the laws we have here in the US. So if they differ where you are, you know, that's another thing. Make sure you know your laws, your traffic laws for what you are and are not allowed to do when you're driving a vehicle, lights and sirens. And a lot of that will go into a lot of your when you stop and when you have to stop and when you don't have to stop. Again, going back into recognizing when you have to stop, your reaction time when you have to stop. So knowing your traffic laws also goes into knowing when to brake and when not. So, you know, that's something everyone should be familiar with. So as we're going around a corner, and we talked about the forces involved in stopping and the time it takes, but now we also look at the forces when we're going around a corner. These are the lateral forces. We call these G forces. They're measured in percentage of gravitational force. So basically, when we go around a corner, forces are trying to push the vehicle off of the road to the outside of the corner. Very, very much like a centrifugal pump, water comes in the middle and it's spinning around and it's trying to fling, and it flings the water to the outside of the pump. That is what's happening when we turn a corner. So this is where, if we go back and we think about that traction circle comes into play, the tires resisting. So there's forces trying to push the vehicle out to the outside of the corner. Forces from the tire, between the tire and the road, are trying to keep the apparatus on track going towards the inside of the corner. So as long as the force at the tire is greater than the force trying to push it out, the lateral G force, we'll be able to go through the corner just fine. Well, if we go through too fast, that lateral acceleration, that lateral G force, will become greater than the forces that the tire can generate with the road, and then that will end up pushing us off the road if the force is too great. Another reason why we want to try to go slower through a corner than we actually think. If you think you can go 50 kilometers an hour through a corner, it's probably a good idea maybe to go 40. One thing I've been taught is, if there is a speed for a corner that's labeled with a sign by that corner, you should always try to go at or just below that speed that's been posted for the corner. People who designed the road determined that that was the speed that vehicles would not, go off-road on. So off the road if they went through the corner at that speed. So we should try to adhere to that. Like many things, we can argue all we want, but we can't change the laws of physics when we drive. So we need to, kind of adhere to some of the speed limits going through corners, because they've calculated out the forces that'll be generated if we go faster than that most tires won't be able to keep to counteract the forces and will slide off the road. Now, going along with just sliding off the road is with the higher center of gravities on the most fire apparatus, that center of gravity will tend to shift more, and especially since most of that weight is water, it'll also slosh over a little more. And when that center of gravity, as we see on the right, gets closer to the edge of the tire, the base of support, as soon as we get over that edge, the truck will roll over. So that's another thing we have to be concerned with. This is where also, like, having good maintenance comes into play. If you have broken springs on your fire apparatus, it won't resist the weight transfer as well. So you'll get more uncontrolled weight transfer onto that outside tire, which overworks that tire because it's now more load than it was designed for. And you're not getting any help from the inside tire when you go through, because all of the weight has shifted to the outside. So those are things we need to understand, that the faster we go through the corner, the more of this weight transfer occurs, helping to overload the tires, also helping to shift the center of gravity outside of the base of support. It's been found and proven, unfortunately, on many occasions, that fire apparatus have a tendency to roll over. And it's not just due to a bad design, it's because we drive them too fast and we corner too fast. So normal car it can maintain about 1 lateral G before it rolls over. On a fire truck, because of the high center of gravity, the different tire construction as far as the counteracting force, it can only do about half of that. So about half a G is when a fire truck will actually roll over. So again, that G force is all related to how fast we go through a corner. The faster we go through a corner, the more likely we are to roll a vehicle. So, it can be, and the tighter the corner, the faster we go through, the more likely we are to roll a vehicle. No, it's possible on a sharp 90-degree turn to reach the rollover threshold of most fire apparatus going somewhere between maybe 10 and 20 kilometers an hour, if not less. So when you think you're not going very fast around a sharp corner, when it comes to the rollover threshold and the lateral forces generated trying to push the truck over, you're actually going very fast. So that's another thing to consider when we're going through. If you make quick, jerky movements when you move your apparatus, there's more of a tendency to have those, basically the tighter turning angles, which will also have a tendency to roll the truck over. And then one of the other big things we found, speed, all of these braking, rolling the truck over, going out of the corners, these are all related to speed. And then the next thing that we found really goes against safe driving and it makes accidents is unattentiveness. So, not paying attention to the road, being distracted, sometimes even tunnel vision where you're only focused on the road ahead of you and not what's going on to the sides and coming out of side streets. So that's not knowing your speed, knowing the traffic conditions, not knowing if you're on the road or off the road. I've seen people slide off the road because they weren't paying attention and almost hit a telephone pole because they didn't get back on the road in time. And actually, once a fire engine goes off the road, when trying to get it back on the road is when we can have a lot of rollover accidents because of that very tight turning radius and not being able to take the lateral G force from on the corner. So instinctively, as soon as you go off the road and you feel that tire drop off the edge of the road, you want to just quick jerk the steering wheel back and get back on the road, which a lot of times we end up overcorrecting. When the tire actually jumps on the road, now we shoot across into the wrong lane. We overcorrect again to get back in. And when we correct to get back into the other lane is when we take and turn too tightly, too quickly, and the fire apparatus rolls over. So even if we're running in emergency mode, if you drop a tire off of the asphalt onto the side of the road, we need to stop the apparatus. And then once the apparatus is stopped, turn the wheel in the direction you want to go onto the road and slowly get back onto the road. Once you're slowly and controlled back onto the road, then you can continue on to the incident. So, kind of starting to wrap things up is driving faster is never the right answer. We don't do any good if we only get halfway or less there. So think about what the end result of our action is. The end result is we want to get to the fire scene to put out the fire, to rescue the victims in like an auto accident or any other type of technical rescue. If we don't get there, who is going to help them? And if we end up in an accident, who's going to end up helping us? And do the people helping us take away from the people needed to help the community in their emergency? So we have to look at both of those things. So a lot of times slowing down and just making sure we get there as opposed to driving fast and not getting there makes a big difference. So our summary of our safe driving points are: slow down, always wear your seatbelt, pay attention to what's going on around you when you're driving, make sure you keep a safe distance between you and the next vehicle. You know, even when I'm not driving an emergency, just when I'm driving to and from the station, I always keep a distance between the next car. One of my old officers told me, he said, always make sure you can see the bottom of the tire of the vehicle in front of you. If you can see where the tire and the road connect on the vehicle in front of you, that gives you enough room if you need to swing out. And, you know, if you're just going back to the station from an emergency and you get another emergency, that means you're going to have enough distance that you would be able to swing out and be able to get and go down the road if you had to go to respond to another emergency. But that's just something I've always kept in mind. Even when I drive my own personal car now, I always make sure I leave that much distance in between my vehicle and the next. Know your apparatus, know how long it takes to brake, know how it handles. This is where, if you have the opportunity to go to a training ground or an open area, you know, an open paved area where you can set up and go a certain speed and then stop the apparatus and see how long it actually takes you to stop the apparatus. Go through a few slow turns just to get an idea how it handles when you turn. You know, that's all knowing your apparatus, how it's going to handle when you do certain things to it. Know the area you respond in. Some of the crashes that I've researched, actually that was a contributing factor. The people going to the emergency didn't know the right route or was unfamiliar with traffic patterns. They ended up getting distracted by trying to figure out where they were going, and that was part of the reason for the accident. So, and that pretty much is everything I have for, you know, our safe driving. It's very, you know, we'll talk in the future at greater lengths on this, and this is always something that it's always good to come back to, looking at developing driver training programs. You know, by looking at some of the codes in the US, you know, your driver training program, your drivers should be trained twice a year to make sure their skills and their knowledge are up to date and kept fresh. So I'm going to hang out. I'll be around for any questions, and I'll set through tea times. And I'm really, you know, this, like everything, this has kind of come from my perspective as doing this in the US with our laws and our traffic regulations and how our normal traffic flows go. I'm interested in learning any challenges or anything different as far as how you operate, and, you know, so maybe in the future we can better adapt this to fit how you operate.
Awesome. Thank you, Ed. Great points. And I know a topic we've been talking a lot about as we've seen vehicle accidents, both here in the US and in parts of Africa where we've been working with fire apparatus involved. So thanks for the training today. Guys, stick around for some tea time. Please do go ahead and fill out the training evaluation. We do look at that, especially when we're developing new topics, and have some great trainings coming up